this unit. So like number 1 through 4 on the homework are all difference quotient. We're not going to worry about that. But I am worried about the rest of the stuff. So derivative tells you the slope of the tangent line, or like the instant slope at that point. So here they're just kind of giving it to you. We're just building up to like where we can take the derivative. So they're giving you this original equation, y equals x squared, and then they're telling you the derivative is 2x, which is just that rule I showed you last week. Like you bring down the 2, leave the x there, and then reduce the power by 1. And they're just giving it to you though, because we technically haven't done that yet. And then they're saying find these things and like tell what they mean. Or I would like you to be able to tell what they mean. So the derivative at 1 would be plug 1 into the derivative equation, and you'll get 2. And what that tells you is the slope of that tangent line that would just brush up against the graph at x equals 1. The slope of that is 2. If I go to x equals 2, plug 2 in, I get 4, which makes sense that it's bigger because by the time I get up here, my line is a lot steeper. So it looks something like that. And then at negative 2, you can kind of guess what the slope's going to be at negative 2. What do you think? I mean, you can tell by plugging in 2, but it's symmetric, right? So if it's going up with a slope of 4 on this side, it's going to be going down with a slope of negative 4 on that side. What is the derivative, or the value of the derivative right there? 0, because our tangent line would be horizontal, so it would have a 0 slope. Those okay? Number 1 is saying, here's your derivative. Find the derivative when x equals 2 and explain what it means. So f prime of 2 will be 5 halves minus 2, which is like 5 halves minus 4 halves, so 1 half. And that's the slope of the tangent line. Or you could say like instantaneous slope. So after 1? Yeah.
If we were to just say that, is that good enough, or do we have to say when x is 2?
You probably should be saying when x is 2. But I don't, it's a multiple choice type of question. So it probably won't matter. But yeah, when x is 2 is good. And to me that's freaking obvious because it's right there, but no, I know. The frickin' was not directed at you, it was directed at the AP folk. Okay. Number 2. This is an important thing to understand the difference between. If I'm at the f of x level, I'm dealing with the amount of something, or a distance, which is still an amount. It's like an amount of feet. If I'm dealing at the derivative level, I'm dealing with a velocity, or a rate of change, which has to be like something per something. So when I'm looking at number 2, they're asking me like 2 different things. So interpret, what does it mean if x is 8 and y is 1500? And what does it mean if x is 3 and y prime is 161? So this part A is not a calculus type of situation. It's saying x is the number of minutes. So I've ran for 8 minutes, and that means I've run 1,500 miles. 59 miles, that would be a little ridiculous. Meters? Probably meters. So, after 8 minutes, I have run. Have ran 1,500 meters. Right? Is it wrong?
That's right. I just Packer would yell at us for saying half. This isn't an English class. I know.
What would he yell at you
I
for?
think it's run.
for having, I think it's have run.
It's either I ran 15 meters or I have run.
Yeah, that's right.
Okay. The math part we're good with?
Yes.
Okay. This is not like an accumulate. So this like accumulates over 8 minutes, like just like adding on how much I ran. At the end of it, I've done 1,500. This is not accumulating anything. This is at an instant moment, and it has to be a rate. It has to be a velocity. It has to be something per something. So what this means is specifically when x equals 3. So on the exact third minute, I guess like during the third minute here. My velocity or my rate, so my velocity is 161, and then I gotta look at like watt per watt. And they're giving me meters and minutes. So it'll be like 161 meters per minute. So this is a total amount, 150, and this is a rate because now we're dealing with a derivative, which tells us that we're changing. So we need to put like a velocity type label on it. Whether it's meters per minute, miles per hour, gallons per second, whatever. Does that make sense, the difference between those two? Let's say water is leaking from a tank at g of x equals negative 2e to the t times cosine of t. I don't care about the equation. Plus 80,000. So that would be like there's 80,000 gallons in the tank, and then it's draining at this rate. G of 10 would tell me how much water is in the tank after 10 minutes or how fast it's draining at the 10th minute. Amount or rate? Amount. So G of 10. Hold on, I should write this better. Water's draining from a tank still, but this is the number of gallons. So that's how many gallons are in the tank. So G of 10 equals like, basically it's gallons. Well, we good? Okay. G prime of 10, what would the label be on this? This is what I really like. It would be gallons per hour or gallons per minute. So G of 10 would be how many gallons are in the tank at the 10 minute mark. G prime of 10 would be like at this exact moment in time, what's the velocity that the water is leaving or leaking at. So G is an amount and G prime is a rate. That's a huge, huge concept. Think about physics. I don't know if you've got quite this far, but if you take the derivative of a position graph, so position is like feet, right? What's velocity? What would the label be on velocity? Distance over time, so it could be like feet per second. So that's an amount. That's a rate. And velocity is the derivative of position. You guys done that? Like looked at the position graph and taken the slope of it, and then you get to velocity. So slope is derivative. Slope is a rate. So feet and velocity are another example of this. Feet is an amount, like I've gone 200 meters in 10 minutes. Velocity is a rate, like I am right now going 200 meters per second or whatever it might be. I don't even know which one of these is which. Is this the dy over dx? So this is like f. This is like f prime of x. This is dy over dx. They both mean derivative. I've never in my life had to know which one was which. But alright, so the next big thing in here is the tangent line problems. So again, you do not have to do numbers 1, 2, or 3 and 4 here in his work. Or 1, 2, 3, and 4 in the actual practice. Because those are different quotient. We're going to be finding that. Let's do Let me go to your homework and do like number 9. Let's see. And then I'll come back. I think the ones in the like his notes are harder than these, so I'm gonna do these and then come back. The equation of the tangent line. That's just the equation of a line. Is something you'll be asked to do very often. So, kind of the general pattern that gets used is that. Where that's the y value, which comes from f of x. This is the x value, which is x. And then this is your slope, which comes from f prime of x. So if you give me a point and then a direction, a slope, I can draw a line. So that's what this is giving you, basically a point and a direction, then you can find the equation of that line. So here they are giving you that is the point 5, 7 in the original graph. And they are giving you negative, nope, sorry, that's not true at all. 7, 5. 7, 5 is a point on the original graph. And 7, negative 2 is a point on the derivative. So I might be making this more complicated because I'm trying to like teach the issue with it also, but it's not that bad. So what's the x value of both those points? 7, it goes in that spot. M is your slope. Well, slope and derivative are the same, so when x is 7, what is the slope? It's negative 2 because that's the value of the derivative. So the value of the derivative is your slope. That's your f prime of x. And then the y value is from f of x, and that's 5. And that would be the equation of your line. Is that alright for that one? They do get a little trickier. I don't want to do too many though, so I want to save you some. So I'm going to do number 11 next. So I'm just going to start off y minus blank equals blank times x minus blank. Always my go-to for the equation of a tangent line. I should probably show you where that comes from. Do you want to know where that comes from? Slope is y2 minus y1 over x2 minus x1. Right? This is like rise over run. Multiply both sides by that. And you get exactly what I have here. So this is just the slope formula, like rearranged. Is all. That helps or makes it more confusing, but there it is. So for this one, what's going to go right there? Next to the x goes the x value. X value is negative 2. So that'll end up being like a plus 2, but that's where that goes. What goes here is the y value. Do I get the y value by plugging it into f or plugging it into f prime? Plug it into f. So this is going to be f of negative 2, which is 3 times negative 2 squared plus 2 times negative 2, which is 8. Agree? With me? And then that last blank is the slope, and I get the slope by plugging into the original or plugging into the derivative. The derivative. The derivative tells you slope. So I want f prime of negative 2, which is 6 times negative 2, plus 2, which is negative 10. Questions on 11. Where'd you get this? Why did this happen? What if this? So like 12, 13, 14, those are all the same idea, right? You just plug it into one or the other and know which way to go from there. I'm not saying you won't have questions, but I think that will get you like going at least. Let me go back to the top because there were some more difficult. Again, skip 1, 2, 3, and 4. I don't care about them and they take forever for this stuff. Other than that, though, they're totally fine. I want to go back to like the notes part of number 5 and 6. So for 5, I see equation of the tangent line, so I'm instantly just writing down a general form. What goes here is my x value. So I know my x value 2 ways. One, they tell me right there x is 5, and one, they tell me right there x is 5. So I'm putting 5 in for x. I don't see the original equation, so I can't plug in to find the y value, but they did give me the y value. What's the original y value? This -2. I know that's the original because they plugged into h, not h prime. So -2 goes there. And then my slope comes from plugging into the derivative. Well, that's my derivative. So if I want the derivative at 5, I've got to do 5 to the third. Seriously, why? What's the point of that? So I plug 5 into there. 5 cubed is 125, -2 is 123. So seriously, we're going with 123 fifths here. Is that right? Like, even I feel like I got it wrong for some reason. That's just a stupid number. Yeah.
Hypothetically, could we not find the original equation if we know?
You can actually, because second semester we do integration, which is derivatives backwards. And with that information and this combined, we could.
Dude, stop asking hypothetical questions.
It's not like we're going to get to that. Okay. 6, same idea. So y minus blank equals blank times x minus blank. So they're giving me this guy. Or right there. But what that's telling me is the x value is 2 and the y value is 7. So the x value is 2, y value is 7. So what I'm missing is the slope, right? I don't have like f prime of x equals blah 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 to plug into. Normally I would take like my x value of 2 and plug it in here. And whatever that told me is the slope. So I can't plug it into this, but can I plug it into the graph? Like I can read a graph, right? So this is your derivative. So be careful, because you don't want the slope of this. If you take the slope of this, you are taking the slope of the slope, and now you're at the second derivative, which we will get to, but I don't want to get there yet. All I'm saying is if the x value is 2 on this graph, what's the y value? It's 3. But this graph is not x comma f of x, it's x comma f prime of x. So then when x is 2, what's the value of the derivative is 3, which means the slope of the original graph is 3. And we can't see the original graph, I don't even know what the equation is. I have enough information to say, okay, this represents, the y values here are slopes of the original, and then I can grab that number and throw it there. Questions on anything I went through up here? Okay, so keep going on 2-2. I don't want to continue. Tomorrow, so this is the other thing I wrote in the notes. Don't do the notes for 2-3. It's him going through the TI-84 and showing you how to do everything in the calculator. We have the 89, and they're much better. So I'll just show you in class tomorrow. Don't do the notes for 2-3. Class Thursday. Just so you right now.
We're not
11. You should have 2-4 done by Friday. But get working on these and check them, and please tell me if I can help you.